Can someone confirm, please? Is it audible? Somebody unmute. Okay, sorry. I think I should allow you to speak now. My bad. 1 minute. The option is given. You can unmute and speak somebody. Can you see the screen?
Yes, sir.
Okay, thank you so much. Salma Begum. Okay, all right. In the last class, I think we started with the class quizzes also. Hope you are also aware that you took the assessment. So today also we have the second quiz, which is already assigned to you. Hope you can see. And what we covered in the last class was that network management standards, different models, and the language that is being used inside the used for the network management. That is abstract syntax notation, ASN. Okay, so we did discuss about this pattern. I think more or less even quiz 1, quiz 2 is also there. I don't know how they will distribute the marks. I'm not sure. That anyway, bits will communicate to you. So standards. So what are the protocol standards that we have? And then the management models, the language, that is what we are going to look at it. So as you know, there are multiple organizations, international organizations, which have come forward to provide the standards like OSI, then SNMP, TMN, IEEE, then web-based, etc. are the different standards what we have. So out of which the architecture and the model was more or based on the OSI reference model only. That's why it is also called as the OSI network management model, which will say that the network management can be broadly categorized as the organization model, information model, communication model, and the functional model. So basis this, organization model will talk about the network management components, functions of their components, and the relationship among the components. Information model consists of SMI, which is called as a structured management information thing, and MIB called as a management information base. So SMI talks about the syntax and semantics, whereas MIB talks about the organizing the information. The management information in this is what we call it. I muted the participant. So this entire information structure model is based on the object-oriented notation. So then we have the communication model, which basically talks about the transfer of data in the bidirectional messages, and the transfer structure, that is the protocol data unit, which is being exchanged, will be discussed as a part of this. Then lastly, the FCAPS, so which is going to be a a functional model, which talks about the configuration management, monitor components, measure performance, then secure information, and then the account usage related to these things what we saw as the different functional models. So TMN architecture basically addresses the management of telecommunication network based on the OSI model. It's a superstructure of the OSI network. It addresses the network, service, and the business management. So this is how the TMN architecture would look. So these are the different telecom operators map. with respect to the service management and the network management. Then we have something called as the ETOM, which is going to be operator related thing. Okay. So basically it's an extension of the thing, telecom operator. Then so customer service provider, there are a lot of third-party services are also being involved. So that's why implementation decision, support wise decision, then awareness and create that how to do the or how to utilize the operations or the resources which are going to be available. So based on this, we have a inventory, fault management, billing, service activation, quality of services, etc. The network management is based on the agent managed devices, then management databases, which is entirely embedded in the network management station. So coming to the organization model, each and every network node or network element to be managed should contain the network components, which are just nothing but the manager, agent, and the managed objects. So manager is responsible for sending the request to the agents, monitoring the alarms, houses the applications, provide the user interface. That's the manager duty. Agent basically gathers the information of the managed objects, configures the parameters, responds to the manager's requests, generate alarms and send them to the managers. Agent is built into the network element. It's a part and parcel of the network element itself or managed object itself. So for example, say hub router. So see, it's not simply hub, it is a managed hub. There could be a non-managed hub also, which will be manually managed. Whereas here, these are all automatically managed. Software will deal with that. So managed objects are those which are the network elements and that need to be managed. Houses the management agent, all objects are not managed. So only the manageable devices are going to be managed. So we have the manager with the MDB, that is a management database, then followed by the managed objects, and within that managed objects also there is a category of unmanaged objects as well. So MDB management database, agent, process, etc. are the. So there is a three-tier model also possible where manager, agent or manager, then the managed objects, which contains the agent process also. So manager and agent or manager will also have a separate databases. MDBs are different. This is called a three-tier model. Manager layer, agent or manager layer, then the managed object layer. That's the architecture. Then there is also possibility like 3 tiers or 2 tiers things are there. Those things can be managed by the manager of managers. We call it as a MOM, manager of managers. So one element to another element, we can call it as a peer network management solutions. So we can view that with the help of 3 trees. One is inheritance tree, containment tree, or registration tree. So inheritance tree is top level network element switch or Ethernet switch. Containment tree could be network element which contains a module or interface or the physical address corresponding to that. That's called the containment tree. Registration tree is starts from the ISO, ARG, Department of Defense, Internet, then the several management. So that's the thing what we saw. So SMI and MIB are the two things which I told you. One is talking about the syntax, other one is how do we place the information. That is what we consider. Then SMI and MIB are the uses the different things like syntax, semantics are going to be defined by the SMI. So syntax is acted string, definition is a actual description of the entity, access is read only, status is mandatory. Whereas MIB is basically houses the information. It could be a agent MIB or manager MIB also. Both are possible. So managed objects can be hubs, bridges, transmission facilities, etc. They are called the network elements. Basically, they are hardware devices. Then software is non-physical programs and algorithms. Administrative information could be a contact person, name of the group of objects, like that it will be. Managed objects are uniquely defined by a tree structure defined by the OSI model. So in a different levels. So now the designation we can apply with respect to the route to the ISO, ISO to ARG, ARG to DOD, then internet. There will be numbers associated or address associated with this. For example, say ITU means 0, ISO means 1, ISO ITU means 2, like that. Now, if we talk the entire path, it will be 1.3.6.1. That is the internet we can say. Further to internet also, you can go like management, directory, experimental, private, security, SNMP version 2, system 1, interface 2, like that. You have a different things to follow the path. Yeah. This is the view in terms of browser view. This is the normal tree view. So object type and instances are going to have a object identifier, the name and the descriptor corresponding to that. So that will be there as a part of the things. So object name is sysname. Syntax is in the form of octal strings. Then definition is the name of the system. Status is the mandatory. Access is the read-only kind of thing. That is the way we able to do that. So object type can be accessed, have its own syntax, which is model of object. Definition, that is semantics, textual description. Status is implementation requirement. Then we have the language to represent, that is called as the ASN, abstract syntax notation .1, which is more than the syntax, and it is the language by itself. This one will going to address both the syntax as well as the semantics of the things. So abstract syntax is a set of rules that specify the data type and the structure for the information storage. And transfer syntax is going to be the set of rules for communication purpose. And there is a machine readable code, which is called the basic encoding rules. BER is going to be generated in order to used in the management model. So now the communication takes place between the two users is that based on the local storage and the application component. So user can communicate with that and application can transfer the data in the several ways. That is transfer syntax is used and application to application, it is an abstract syntax. So other alternate to BR or PR, DR and CR are the things. This is the network management model. So conceptual view of this entire thing we discussed. Then with respect to that, how do we define within the ASN that we discussed? The data types include Boolean, integer, bit string, then octet string, date, time of the day. So date and time put together, enumerated data and object identifier, sequence of choice, visible string, null are the data types which are being used in the ASL. Yeah. That's it. I think we discussed about this only. So then finally we touched upon the FCAPS, that is the fault management, configuration management, account management, performance management, and the security management with respect to that. So today we continue our journey in understanding the SNMP version 1. Continue our journey in understanding the SNMP version 1. Is there any questions for me regarding the previous class? It could be any questions, so need not to worry about it. Okay, all right. If you do not have any questions, let us continue with the today's agenda. So today's agenda is the SNMP version 1. We are in the session 4, SNMP version 1. So what basically organization and information model with respect to this? So AI intelligence techniques for the network management, web-based network management, cloud management, and autonomic network management. Networking is what we want to see. So Internet Engineering Task Force, IETF, in the year 1990 managed to put this in the SNMP version 1. So in 1995, the refined version of the SNMP 1 is come, which is version 2. And 98, after 3 years, SNMP version 3 came, which is the stable one now. Okay. So Internet Documents, request for comments, we call it as RFC. IETF standards, that is the Internet standards, and FII for your information. That's the SNMP version, organization and the information model. So this is how the whole world was managed for the network. Is there any breakdown or something has happened? All those things were monitored in this way. So SNMP management is also referred to as an internet management. Because network of network is called as the internet, right? So any network which uses the TCP/IP protocol suite is an ideal candidate for the SNMP management. So SNMP network management system, we also call it as a network management system, so that can manage even non-TCP/IP network elements also. But at that time, they use something called as a proxy agents rather than the SNMP agents. Okay. So the management is the most widely used network management system in there is SNMP. Most network components have the network agents built into them that can respond to an SNMP network management system. A host or a bridge or a router that has an SNMP agent which is built in. So SNMP manager, there is a SNMP agent. between this communication protocol is the SNMP. Stands for Simple Network Management Protocol. There is a server, there is a multi-layer switcher, there is a router. These are all having a agent placed on them, each of the objects, and these are called the managed objects because they can be managed, and there are some elements which could be unmanaged also, which need to be managed with the manual method, whereas the SNMP will manage this entire thing with respect to the this diagram is very important, guys. If you have a questions, you can ask. So this is where we wrote that SNMP manager. So manager will have the manager DB, something like that now. So that is where important. If you understand this, then most of the things will be like that. So this is the manager. Manager will be attached to the MDB. Is a database.
Hello, sir.
Huh.
Any
Yes.
real example of SNMP manager system?
We will see that further. Okay. Every this thing will have that. I'll let you know. You first understand that what is manager, what is the agent, then how do they communicate. So for that purpose, we have the protocol, SNMP protocol is there. I'll give those examples also.
Okay,
so
sir.
then this manager will going to be having leads to an element which is connected. This is called as a managed object. And this will also give a place for the agent to sit. That's the this is the basic understanding of your entire. Right. So now the way these two are communicating is through the protocol called as a SNMP. Of course, alternates are also there, but they were not so popular as a SNMP because it's a very robust kind of thing. In the beginning itself, it was intended for the internet. So that's where it has become very, very popular when compared to other models. So this is how the SNMP is going to be there. So every element, or this is your network, right? This is what we saw. For example, say we understand that this is the network. This entire thing is a network. Now, what additionally you are looking? If they are all managed devices, then there will be an agent and data will be there. Agent and data will be there. So for which to be managed, there needs a manager. For this entire network, maybe you can think of one manager. Okay. Clear? For example, say you take your house broadband, correct? There is a device. There is a device. Do you think that this what we call that broadband modem, this broadband modem, do you think that you are managing it? No. The service provider will try to have the manager to manage this entire thing. Agree? For example, say this keep on blinking, etc. You can see that, observe this device which is here. See, power is there, power on network authorization, internet, what is the speed 2.4 or 5G, then is the telephone connected, LAN 1 connected, LAN 2 connected, LAN 3, LAN 4, then WPS. What I have done is I have connected this wire, that's all. In case whenever I wanted to plug, I can use this. So that's why there is a light indicating it. So this device is a managed device, which will also houses the agent. Means you may ask, sir, where is the agent, sir? How can I see? No, you can't see because it's a software layer. The hardware is the broadband, which is called as a managed device. That houses the agent. There is a software, maybe in the form of some chip will be there, like what is that, RAM kind of thing. That will have the software integrated. Okay. Now there will be a maybe every 12 hours or 15 hours or 20 hours there could be one connected device maybe there. So there is a manager which will going to see that this manager is these devices, these many devices are working properly or not. So for this manager, there is a manager of managers could be there. It could be from your telephone operator or maybe what is that, Airtel, or it could be even today you can see that fiber to home, like just like your what we call cable TV. No, the same way there are cable operators are also providing this type of thing. They may be putting one fiber object fiber, and that fiber would have been carrying the signal. So there they would have another manager to manage. I hope it's clear now. The real example. See, it's again, the entire thing is a software, but there are devices which will go into hardware, which will be, can be managed. And every physical device or a hardware will carry the internet, IP address. Address will be there. So that is what exactly it does now. Hub 1, Hub 2, router, then router 2, then the network management system, NMS. Here guys, this we call it as a managed LAN. If you are not managing it, then it will be a manual configuration. Manual switches will use instead of this router. Managed switches we can use. So then configure the intent. Once the network components have been discovered and mapped by the NMS, we can query and acquire the information on the system parameters and the statistics on the network elements. Okay, the network elements. So how do you define that entire thing? Again, ISO, ARG, DoD, Internet, private enterprises. So now Airtel could be an example of it. So from Airtel enterprise to the area, this entire thing we call it as a system. How you can identify that? In our picture, we saw hub 1 is there, hub 2 is there, then router 1, router 2 is there, right? See, hub ka details. Second hub ka details. So system information on the router, how it is going to be there. So in order to identify this, you might be using a ASN, abstract syntax notation. Through that, it is being identified. Okay. So different ports on which it is going to be used. So logical link address will be there, that we call it the MAC address. Then followed by the interface IP addresses, So network mask, network IP address, all these details are there in the form of. So where it will be stored, it will be part of the network management system, SNMP. There is a manager, no? So this is what we said, right? 192.168.1.0 will have this information. Will have this information. See, that's why we say hub is a simple divisor, whereas router, you see how many entries are there. That's why it is a complicated device. Or next level hierarchy, that is much advanced. The organization model talks about the relationship between the network element, agent, manager, and the hierarchical architecture. Whereas information model uses the ASN.1, that is the syntax, abstract syntax notation, .1, and uses SMI, MIB, like how we discussed in the last class. SMI is the structured management information, which will be basically talking about the syntax. Then MIB is the way the information is organized, that will be stored in the MIB. Of course, there should be a communication model, like transfer of the syntax, then SNMP over TCP/IP, how that protocol will work. Then communication services addressed by the messages. Then security framework, community based on the model. For example, say I am able to explain, you are able to understand, you are attending my class is because both of us speak English as a common language. So that's the reason why we are able to do. If I use a very strong, like, Oxford dictionary level new words, if I use, some of the words you will not understand. The reason is that, so which is not defined in your mind or in my mind. It could be opposite also. Right? So then communication services are addressed by the messages, and the security framework, basically like our FCAPs, which we talked, right? That will also come in the picture. The SNMP manager, which is basically called as a NMS, network management system, which is going to use trap or information listener. As a manager, it is keep on sensing or monitoring the things. Do you agree? If any of the node is not responding, then it will start diagnosing it. Yes or no? So that is exactly we need to do now. Now, I sometimes raise the question that is my screen visible? Please confirm. I'm keep on listening to your this thing at a information listener. Suppose I may be trapped. One guy asked the question now. So now I'm listening to the question. I'm giving attention to that guy. Others, I might not listen. So it's called as a trap or listen mode. So then management definitions, different managed devices. So for each of those managed devices, there is an agent management definitions, management database will be there. Okay, for each of the device, and overall there will be an agent layer, and this agent layer will communicate with the SNMP manager through the agent which are associated to each network element. That's called the SNMP model. If it is a two-tier architecture, okay, so SNMP manager will be there, SNMP agent, and the network element will be there. Or it could be a manager of managers. So multiple managers can also manage the one device. For example, say 70 people are there in the class. all the 70 people might raise the question to me. Possible, no? So like that. So these are all again the software modules, as I told you. Network agent process resides on the managed object. The network manager process resides on the network management system. The network manager receives the raw data from the agents and processes them. So based on the traffic statistics such as input, output, and packet per second, so some statistics will also be there. So this is the three-tier architecture. As we told, when we are using a three-tier architecture, instead of the network manager continuously monitoring the events and calculating the information at a certain data rate, we will use an intermediate agent called the RMON. We use the intermediate agent called the RMON, which stands for remote monitoring. This is inserted between the manager object and the network manager so that your load of the manager can be bypassed. This is not a proxy. Don't mistake it for the proxy. This is an additional device or additional agent kind of thing we insert between the intermediate to monitor the things. Of course, in Arman also a lot of versions are there. Arman 1, Arman 2. I think this we will going to study a post midsem, I think, if I'm not wrong. We also use proxy. Why do we use proxy? Suppose say all of them are OSI related, OSI reference model related network, then the protocols, etc. are homogeneous. If you use another network standard, then it becomes a heterogeneous. In such cases, what we do, we use a proxy, which will going to convert that format to the requisite format. That's why we call it as a proxy servers are going to be used. So these proxy server will also manage the non-SNMP managed objects. What do you mean by non-SNMP? Which will not be using SNMP protocol. Other than the SNMP protocol also they may be using. In such cases, we will use the for example, say pure SNMP management system consists of agent and SNMP manager. Whereas an SNMP can manage the network elements which does not have an SNMP agent at all. Some other agent is there. For example, say management of hybrid fiber coaxial HFC access system outside the plant and customer premises equipment in the broadband services, where they are using amplifiers and cable technology is different than the normal managed object. So you can think of this entire thing as a again one to another one communication will happen in the form of a client server model. Manager is your server, client is your agent like thing. Okay. So what is the difference between agent and a manager is that manager will have a managed DB. MDB will be there, management database. Otherwise, agent will not have it. I repeat, the major difference between the manager and the agent is that agent doesn't have the DB, whereas manager has the DB. That is a thumb rule or simple way of defining it. So in order to transfer the PDU, protocol data unit, you should have a network, correct? Now you will have a physical layer, data link layer, internet layer, transport layer, then the application layer. So where is SNMP now? SNMP is a protocol. So obviously it will be an application, sits in the application layer. Well, it's based on the internet. No, I told you 1990 this was introduced, and internet was the major thing for which it is adopted. Now, what does the communication happens? So there is an SNMP manager application and there is an SNMP agent application. They try to exchange the information in the form of get request, get next request, set request, get response, trap. There are 5 messages being exchanged. Anything, questions if you have, please ask. Okay. All right. If you do not have questions, let us proceed. Data path between the manager application process and the agent application process via the 4 transport function protocols, that is UDP, IP, data link control, and the physical thing. SNMP protocol has been intentionally designed to simple and versatile. Communication of management information among the management entities is realized through the exchange of just 5 protocol messages, that is get request, get next request, set request, which are initiated by the manager side, and other 2 are the messages which are generated by the agent process, which is called the get response and trap. Message generation is called as an event within the network. I hope these are clear, right? Get request means I'm requesting about the information of the object that the agent is managing. Get next request. So now currently this one step ahead, next request. Then set the request. Set this request to this on, off, or something like that, idle. Whereas agent communicate back to the manager through the whatever the get response and trap that will be sent by the agent. There are 4 services actually: get to, set to, get next to, and trap are the 4 services. Get to, set to, you know, right? Get means receive, set means write, then get next means the next thing should be read, then trap are the 4 services. Don't get confused with the service and the messages. There are 5 SNMP messages are there: get request, set request, get next request, get response, trap. These are the 5 messages. Get request, get next request, set request, get response, trap. These are the 5 things. These are exchanged between whom? Manager and the agent. Which manager? SNMP manager and the SNMP agent. Why SNMP? Because both of them are going to exchange as per the protocol. The protocol is SNMP. Am I clear? So get request basically retrieves the value of the objects in the MIB, that is management information base of an agent. And get next request is also retrieve the values of the next object in the MIB of an agent. Set request updates the value of the objects in the MIB of an agent. Trap request, that is report extraordinary events to the manager. Any something not abnormal kind of thing which has happened will be set. Get request generated by the management process requesting the value of an object. System group parameters are obtained using the get request message. Get next request will going to be similar to the get request object. Might have a multiple values because of the multiple instances of the object. So set requests are generated by the management process in order to initialize the or reset the value of an object variable. Get response is the message which is generated by an agent process and is generated only on the receipt of the get request or get next request or set request from the manager. Trap is an unsolicited message which is generated by the agent side without any message or event arriving from the manager processor. A node can send traps when an interface link goes up or down. Up or down. The get is get request, get response will be issued by the agent. Get next like manager will issue the get next request. Now agent will respond back with the help of get response. Set request, manager raises the set request. Agent will going to write that and give a response back to the manager. Trap is only unidirectional from the agent to the manager, whether the link is up or down, something like that. So in a managed network, there are many managers and agents for information to be exchanged intelligently between the manager and the agent processes. There has to be a common understanding on both the syntax and semantics of this. The syntax used to describe the management information is ASN dot. So which uses the SMI to define MIB or using the BER or OER or this thing. So both SNMP and STMP are going to be. So that is the MIB and the this thing. A managed object can be considered to be a composed of an object type and the object instance. SMI is concerned only with the object type and not the object instance. The object types associated are represented by the identical object. For example, say object is going to be having a object type and the object instance. And now object could be have a name, object identifier for that as per the previous definitions. Then there will be a syntax using the language called as the abstract syntax notation .1 and coding or encoding of information through the BER. So that's the thing. So there are managed objects with multiple instances At that time, object 1, object 2, object 3, like that interface instances will be there at the object instance side. This is what the structure of MIB is going to be considered. So for example, say object type as a name, syntax, and encoding schema. So every object type is uniquely identified by the object identifier. So there is an object name or descriptor and identifier, object identifier. That is how the uniquely we can identify the things. For example, say internet object identifier is ISO org, that is the 3, and DOD 6. Correct? So it becomes 1.3.6. The syntax is going to be basics the ASL. It is used to define the structure of the object type. Not all the constructs of ASN1 dot are used in the TCP/IP based SNMP. BR with the TLV for encoding information to be transmitted between the agent and the processors will also be there. So object names are uniquely defined by the descriptor and identified by the object identifier, which is a unique identifier number associated with each object. For example, say you wanted to have internet object means then it is going to be based on your tree structure. It is first ISO, then ISO identified organization, then followed by the DOD, then the internet. Okay. See, first is this 1 dot, then this one. That is how it will be identified. That's what it says. 1.3.6 like that. Or you can also write it as ISO 1 standard 3 DOD 6 internet 1. Or you can say 1361 also. Or you can also give the names ISO standard DOD internet also. Or sometimes you may write the numbers, which is a combination like the 4th one, 5th one also possible. Okay. So MIB example is going to be based on the enterprise. Okay. So there is a Cisco, HP, 3Com, Cabletron, etc. These are the enterprises which will going to manufacture or the devices, right? Basically, these are the manufacturing. They manufacture the devices. What devices? It could be a router. It could be an what you call switches, or it could be a hub, etc. So that's why internet private enterprises. If there is a case, according to the path, you are supposed to go to 1.3.6. 1. Where is private? 4. Then whatever the thing you can go, right? So that is what exactly they are trying to put it. 1.3.6.1, 4.1, then 9 if it is a Cisco, 11 if it is HP, 43 if it is 3Com, 52 if it is a Cabletron. Like that, it will be identical. So now the data type which are going to be there for the SNMP will going to have a structure followed by the simple or private, defined or application, constructor or structured, followed by the number and the class. So again, this could be a class, could be universal or application, context specific or a private thing. That's also possible. So with this, you can also define the data types here, which is very important. There are could be a possibility of primitive and defined data types could be possible. So under the primitive, we have integer, that is something like, some digits up to certain thing, or it could be a special cases where enumerated integer type also could be used. Acted string is just nothing but the 8-bit 8-bit bytes binary and textual data subtypes can be specified by either the range or the fixed thing. I mean, to represent each of the character, there will be a octet 8-bit number representation. That is your just nothing but ASCII value. Then object identifier, the object position in the MIB. Then placeholder, which is just nothing but a null. Null is going to be used as a placeholder wherever you wanted to fill the gap now, that could be used. For example, say integer 0 to 255, acted string 0 to 255, acted string size 8. Like that you can mention, that is called as subtype. So defined data types could be a network address, dotted decimal IP address, counter, which is a wraparound non-negative integer, monotonically increasing up to increase from 1 to 2 to the power of 32. 2 to the power of 32 minus 1. Gauge is a capped non-negative integer, increase or decrease. It's called as a gauge, please remember. Time ticks is a non-negative integer in the hundreds of the seconds units. Opaque is just nothing but a application-wide arbitrary ASN.1 syntax, double wrapped with the acted string. That's called as a opaque, which need not be. Like the meaning opaque says that mask kind of thing. And apart from that, there are structured data types which include sequence and sequence of are the only two constructor data types they are used to build the list and table. So sequence is a list, table is a sequence of. What is the difference? You may ask a question, sir. What is that difference? One is array, another one is a two-dimensional array. If you say table, there is a rows and columns comes. If you say list, only the single dimensional array will be. Sequence is used to build a list and the sequence of is used to build a table. The syntax is list is sequence type 1, type 2, type n. So only one dimension is there, where each type is one of the ASN.1 primitives. What is that ASN.1 primitives? It could be integer, acted string, or anything like that. The syntax of table is sequence of entry, where entry is a list constructor, means it's a table basically. List maker, for example, say IP address entry is a sequence, not of. If I say of, it becomes a two-dimensional. Since it is a sequence, only one dimensional, we can say sequence. IP address entry address, IP address. Now, what is the data type? This is the IP address, is the IP address data type, right? So that's why it is a. Then IP address entry index integer. So net mask, then followed by the broadcaster address. So again, maximum size that can go is 0 to 65,535. That's the sequence. Whereas sequence of is an IP address table, contains the syntax sequence of IP address entry, access not accessible, status mandatory, description. Like This itself is a one, what we call the sequencer. See? So we can say array of arrays, we call it as a sequence of. Array of array is called as a sequencer. You can have an example here. Object, this things, that thing, etc. So this is a list, is a sequencer. Object which is created from the list of objects, so basic types of object, and each row of an object is a object name, object identity. Rows and columns wherever is there, that becomes a sequencer. These are some of the keywords. So most of them we have already seen, which is the basic data types, right? Integer, IP address, then gauge, counter, right? So this is the things, like they are the keywords which are used in the SNMP. SNMP version has adopted the basic encoding rule with the TLV, stands for type, length, and the value. Type, length, value for encoding the information. So this need to be transmitted between the agent and the manager process means then type, there are thing, length, value. So type will also have again 7 to 8 bits class, whether P or C, then tag number will be indicated by the. So PRC stands for primitive or construct. There is a data type now here. So one is primitive data types, or it could be a defined data type or constructed data type. That's why they are calling it as a PRC. 0 stands for primitive, 1 stands for construct. So then class will going to talk about the 4 classes 0, 0, 0, 1, 1, 0, 1, 1, which is going to be universal, application, context specific, and the private. Okay. So tag number is 1 to 5 bits. So these are based on the TLV sequence. So TLV further followed by the value. Again, value is further divided into TLV like that. That's the. So this is for the primitive, this is for the construct. So for example, say class is could be universal or application, context specific, private, primitive or constructed, followed by the tag number. That's the identifier object. Here are some numericals are there. You better understand here. Example 1, the 32-bit integer 14. We wanted to represent or store 14. What is the value here? 14 is the value. As per the TLV format, 14 is the value. And we have this T and L also. So for the tag is identifier. Tag is identifier. Then length is how much length you wanted. So it says that 32-bit, that's why length will be 100. Means what? 4 bytes it is. 32-bit is what? 4 bytes. So then value is 14. How do you represent 14 in binary or hexadecimal? That is 111110. The remaining 3 bytes are zeros. Since tag is an integer, so that is being taken as a from this hexa code. If you are using octet string, then you say 04. If you are using null, say 05. If you are using IP address 40, like that, the differentiations are there. So based on that, it will be constructed. Now, for example, say I wanted to type hi, H and I. What is the ASCII equivalent of H and what is the ASCII equivalent of I? You have to get that. What is the length of this acted string? Acted string is what? 4. Code for the type code for the acted string is 4. So that means 0, 0, 0, 0, 1, 0, 0. That is the tag. Length is very clear. Only 2 bytes are there. For example, say we wanted to give something like hello. Instead of I, you wanted to say hello. And how many length? 5. That means here 5 bytes will be there, right? Again, H is 48. What is the equivalent of ASCII equivalent of E? L, L, then O. That's how it will be stored. So length will be 5 here. And this remains the same tag because we are using the acted string. Hello. Suppose say you wanted to put a object identifier. That is 1.3.6.1. Then tag will be for object identifier, the tag will be 06. So we have taken it as a 06. What is the length of this? 1, 2, 3, 4, 4 bytes. So I have taken the length as 4. What is the value? 1, 3, 6, 1. That is the third example. Fourth example could be I wanted to store the IP address. Then what is the tag for IP address, which is 40? So 40 is stored. Okay. Then what is the length? 1 by 2, 2 by 2, 3 by 2, 4 by 2. So that's why length is. What is the value? 131, 21, 14, 8. That is the IP address, which is just nothing but a 131.21. Clear, guys? So this is the how we encode this with respect to the ASN. How we store that in the. Any questions there? So an object type of the MIB consists of 5 fields. That is textual value, syntax, definition, access, and the status. For example, say we'll say system descriptor system1, syntax is acted string, definition is so and so, and access is read only, status is mandate. That is the MIB structure. So manage objects sometimes have a multiple instances within a system and need to be represented formally. So an aggregate object type comprises one or more subtypes, and each subtype would have multiple instances with a value associated with each instances. And it is convenient to conceptually define a tabular structure like a IP address table. So for that reason, what we need to do, table entry, columnar object 1, 2, 3, 4, 5, like that we'll write. So that equivalent in the ASN is IP address table 1.3.6. blah blah blah. IP address entry 1, 2, 3, 4, 5. So columnar object will be like this. Okay. This is how we can store the complete path. That we call it as a aggregate object. That's all, guys, for the today's session. Any questions are there? I'm happy to take the questions, sir. Any questions? Okay, all right. There is an assessment associated that quiz 1, quiz 2. To stop recording first.